So our next question is, what are common problem solving patterns in DSA? As of now, we will just go through and understand what are common problem solving patterns. Will not go in depth. That will explain later in other videos. For now, we'll just try to know the names and know about the patterns that we use for problem solving in DSA. So the first one is brute force approach. We can say what it means, like try all possibilities. What does the brute force approach says? Try all possibilities. It is obviously simple and slow, but time complexity is usually bad over here. And what is the purpose of this brute force? Understand the problem first. What it says, what is its purpose? What it says, understand the problem first. So if you're skipping the brute force approach, you're guessing, not solving. Okay, so the brute force approach says try all the possibilities. Second one is two pointers method. Okay, so this uses two indices to scan data. Use two indices to scan data. It works on arrays and strings, we can say, which are often sorted. Okay, so what happens here? Left, we can say right, move toward each other. Okay, what it does, it reduces the complexity of O of n square to O of n. Okay, and what is it used for? What is this used for? Two pointers method for pairs comparison. So our third approach is sliding window. Okay, so here what happens, it maintain a window of elements and slide it. So here in for fixed window size is k, for variable window means that can expand or shrink. And then what it does, it avoids recalculating from scratch, right? It avoids recalculating from scratch. And then what it is used for, right? What it is used for? It is used for sub arrays, substrings, and then we can say maximum and minimum in range. Okay. Here we have the fourth approach, that is hashing. What we call it? Hashing. And that is used for either for map or set. This is used for like trade space for speed. Trade space for speed. And what it stores? Store scene values. And then we can say it looks up n O of 1 average. Okay. And what it does, it eliminates. It eliminates the nested loops. And what it is used for? It is used for frequency count, duplicates, and we can say fast search. So the next approach that we are going to see, that is divide and conquer. So this is the approach. So what happens here? We do break the problem first. Okay. Then we solve it in parts of the broken problem. And then we do combine it, right? What it does, it reduces problem size in each step. Okay. And it is often recursive. What it is? Often it is recursive. And what it leads to O of log n or O of n log n. And what it is used? It is used for merge sort binary search logic. Binary search logic. The next approach that we are going to see is recursion. What happens here? Function calls itself with smaller input. Okay. And what is here? It needs a base case. Okay. Here stack grows automatically. Okay. But what is the beauty of this recursion? It is elegant but dangerous if uncontrolled. Okay. And why do we use it? It is used in trees, backtracking, and divide and conquer approach. So our next approach is backtracking. What is that? It is backtracking. So what happens here? Here we try, we explore, and then we undo, right? What it is recursive and we can say decision tree, right? It explores all valid paths. It does explores all valid paths. And what is the best thing about it? It stops early when invalid. And where it is used? It is used in permutations, combinations, maze, and we can say in queens. Okay. Next approach that we are going to see is named as greedy. So what happens here? It takes the best local choice at each step. What it does? Take the best local choice at each step. So it is fast and of course simple, and but the best thing about it, we cannot say best, the one thing about is that it doesn't always work. So best thing about is fast and simple, but it doesn't always work. Okay, but it is used when proof guarantees correctness. Okay, I mean for intervals, for scheduling. So our next approach is dynamic programming. Okay, dynamic programming. It avoids recomputation. Okay, what it does, store results of subproblems. It goes from top to down, which is good for memoization. Okay, and then bottom up, we can say tabulation. Okay, and it is used when overlapping subproblems.